Andreas Rudenå.
Thank you. So thank you, Tom, for this good introduction to the project. I can probably be a little bit faster. I don't have to introduce that much, but I'm Andreas. So I started this company, Paramountric, a few years ago, or maybe just 1 year ago, because I was obsessed we have the visualization of the environment and supply chains and the flows and the things that I cannot see anywhere. So that's what I wanted to do, and also that Michela said that we are bringing this into other kind of chains or systems that can cause domain interoperability, stuff like that. So it will be super interesting to see what we can bring out. So I want to show the Basajaun project when it comes to the data side, digitalization side, because I'm a software developer, so I bring a completely different perspective. So I'm reusing this image from the top, and of course now you know the forest, the process industry, and manufacturing industry, and construction industry, and then the maintenance phase of the building through the life cycle of the building. So as you can imagine, in data, this is a huge thing to cover all these domains. If you are from the architectural space, you might know the BIM modeling and how easy it is to send the model to construction and you need to do the calculations and get it back. Just inside of the construction industry, we have quite some interoperability issues. So inside of the manufacturing, inside of the process industry, we have a lot of interoperability issues, and this is what we are trying to solve here with this project. Then maybe you recognize this picture. Now I want to break it down from the data. So I start from the building side, and where many of you know this, if you also work with the BIM models and how much data goes into this kind of models. And we are using ICs as the format that is the standard for BIM models. So that's kind of easy actually compared to the other parts. This picture, like we just saw, I want to point out that the details of these components are super interesting, because as we're tracking now the LCA of the buildings, we note that all the small parts of the building from the components are super interesting, because LCA now is a little bit problematic. You know, we have the environmental product declarations, the PDs, which is good because we need those declarations, but those are really like rough, with stuff. It's the full value of this. So we want to do, like, let's say, more dynamic EPDs that really shows. I mean, if you're planning a building, you want to know what kind of impact the parts has, really, like if you're just using different kind of things and where they come from. But now it's not really the case, because the product comes aggregated and then we go back in the tree. So we have a really interesting case here to try to break the stuff down of the hierarchies. So that's from the building side, and this is also from the direction plan of the Rudenå beams, which is interesting also when it comes to timing and planning. So the time is super important, and the time, I'll talk more about the time and processes, and you also talked about processes. It's super important with process of time, and to go into digital twin here, where we call for the model era, we have static data, and we're going into things that change continuously. So you're acting in a flux of data changing all the time, because that's how the world works. It's changing all the time. This is just a small example, because I have this plan that the calculations are also important. So these are the typical traditional calculations that we do for this is facade profiles, and you know about this. This is a thing we need to send to the construction layer or something like that to do the heating performance and the load bearing regulation and stuff like that. Of course, talking about this on the supply chain, we also want to do with calculations and simulation, and we want to do it very often, and we want to do it continuously, or want to do it fast, because things are moving all the time. So we need feedback quickly from the system that we are talking about. So regarding retail plates, we saw it's called it more like you have these different packers along the supply chains, they have their retail plates. In reality, we don't really have retail plates stats. So they have a factory or something like that. But in the kind of division, we are it up that we have retail plates along the supply chain. We are looking into them. In that sense, we're doing retail plate on the supply chain. So yeah, we just do it with the principles because we want to show that this is a real time, it's a process. It just continues to change the world. So it's not about copying data that we're doing out with files or databases or something like that. So this is what we need to do. And what I have been obsessed about is how we show that, because you know, I'm going to go into the system that we're building. It's a lot of backend. It's a lot of things that we cannot see database stuff. So we want to look at. So and it doesn't give you any insights. The data doesn't give you any value. We should cannot put it out there and analyze it and give insights from the data. So this is also what people to work with. Just how we're going from the other side. So we're going from the building side, and then we're going from the forest side. So kind of centralized data and basically mapping out the different kind of forest plots with species and stuff like that, because we need to know the supply side. If the building is the demand side, we need the supply side. This is from a company called Photo Story. That trees this kind of machine learning AI process. This is another picture from Geneva South where I showed let's say their area from the soul meaning of the street. And just now you can imagine how much data we're dealing with there. So to really come from the forest belt, so put this into this system, and they're pushing out, I don't know how many kite they're pushing out all the time, but it's like, it's a lot of data. So now I will come to the other section that I want to show. Understand there's a lot of data to manage. And there's another problem, and that is interoperability between the systems. How do we deal with that? So I have an interesting concept, and we did an experiment. We did a workshop as a home project where we had a problem to understand this. What is this interoperability? How can we solve it? So we did a workshop where we were sitting like this, and we are pushing data into our backend. And we're examining data as it comes in real time, and we're talking about it, and we're discussing it. So in that sense, this data was used to create an information model as a co-creation process. And I just thought it was a fun idea, but now I realize that maybe we should work more on this kind of way to create, let's say, a co-create an information model to learn about interoperability. This is an exercise that actually goes on like a process. It's continuous because the supply chain changes all the time. They're switching out their products to other products. You get them factory and out, so they bring their data. Their data might be different than the other data. So you need to change the information model all the time, which is pain for system developers that really want that information model from the start. But that's not how the reality works. So in this exercise, I want to show you some slides how it might look, but you should really stare and sit the part we stay. But you're pushing data signals, and it comes in on the canvas like this, and you can analyze what it is, and you're continuously sending this kind of data signal, just like IT, but we created some custom interface to be used to form like buttons. So you're basically just feeding data as unified. We can just see how this comes in, and what it is, I mean, in the end, you have to understand that it's like a metadata creation, the creation of format here. So you have to know what is it that you're sending, the semantic thing about the data. When you're sending data and you analyze it, and then you find connections between data. You're continuing, and it gets really complex after a while because you're sending data and you're sending the semantic information of data. So you have to analyze what data is. So this is like for many people, they don't realize that when they talk about data, they think data is we're just sending the data. Yeah, but how we should connect it. We need to know what is the data about. So this is a kind of this an exercise that they're doing together as a group of humans. But in the end, what you want to do is you want to render the data so that you can see that this model works for us. So you have the forest and you have the building, and you can see that. For this example now, we give it in real time. So this is from the exercise. We can see now that we have a connection between all our stuff, really good. So with this set, I went to the next thing, and here I will show some visualization, because when we have the data information on that we're starting to send the data, we can also, of course, do pretty interesting visualization of supply chain, since we know that it's solid. And unfortunately, I don't have the latest version of this, so I have to use some old version of this visualization, but I think we show the idea, and next time I will show you the more fancy version. Here you have the supply chain, and here we have the BIM models. They are actually here in 3D. So you can click on them and spin around and anything, and you have the map on the left side. The viewers there, you can go and zoom in and then check your forest. And in the end, kind of in the between here, you have the wood volume. So the wood volume is transferred to the chain, and in this case, we're looking at the glue line, and there's just all the volume that is used for this wood glue base. Here is the zoom in from let's say the demand side. So this is where we start. We are modeling the buildings, and we're seeing how much it is, and we can click around like they do with CAD program. Then we go to the other side. This is the supply side. We come with the forest, the wood to the sawmill. And what I really want to show now is how this happens when you play it up in an animation. So I need to great. All right, so here's the supply chain is mapped out without any weight band that starts. It comes first. You will see the demand coming in from the right side, which is basically the BIM models, and then you will see the forest is bringing on the volume of wood, and then the other side is just diminishing because these are relative values. You see the different mapping between the classes of the wood timber classes, and how they are sorted into different dimensions and sorted into different kind of wood dimensions, and then it's coming into the forest. Then you have Max. He's supposed to be there also when you're reaching the forest. You want to relax. Really, run over here. Okay, thank you very much.